Let us start with atomicity. Atomicity. Now, what is atomicity? Atomicity is the number of atoms present in one molecule of an element. So, anytime we calculate number of atoms in a molecule of an element or a compound, then we can say that is an atomicity of a certain element. So, for example, if I have O2, now this is oxygen, but how many oxygen? Two oxygen, because of that two. That means this is the same thing as two atoms of oxygen. So now if I have P4, how many phosphorus is this? 4, because of this 4 here. That means this is the same thing as four atoms of phosphorus, like that. If I have Cl, Cl is what? Chlorine. Now, how many atoms do I have here? Do you know there is no number, but there is one? That is subscript 1. But the subscript 1 will not show. That means this is one atom of chlorine. Likewise, if I write ordinary O, now this one means what? One atom of oxygen. Again, if I have O8, for example, O8, this means what? 8 atoms of oxygen. So meaning that we are getting all these atoms, that means indirectly now this one is atomicity of oxygen here is 2. Atomicity of phosphorus here is 4. Atomicity of chlorine here is 1. Atomicity of oxygen here is 1. Atomicity of oxygen here is 8. Why? How do we get that? We just say number of atoms present in one molecule of any element. So that is atomicity. So the definition. So now we can now find a formula for atomicity. So note that atomicity is equals to relative molecular mass, that is RMM, that is relative molecular mass, divided by relative atomic mass. So this is the formula for atomicity. Please note it. Relative molecular mass divided by relative atomic mass. Now, note that relative atomic mass is equal to 2 times vapor density. So Vp means vapor density. So just note this formula under atomicity now. So that means I can also say atomicity is equals to, relative molecular mass. Then I know relative molecular mass is 2 times vapor density, then divided by relative atomic mass. So now all these ones now, they are the formula for atomicity. So now look at the example I have above. So see the example 1 above. So in example 1 above, we have determine the atomicity of each of the following elements. So see the A now. A, an element with relative molecular mass of 160. That means for the A part, what is the data given? We have given RMM, that is relative molecular mass of what? 160, and relative atomic mass of 80, that is RAM, that is equals to 80. So now what is now the atomicity? And we know that atomicity is equals to relative molecular mass divided by relative atomic mass. So now, atomicity is equals to what is relative molecular mass? 160 over relative atomic mass 80. That means the atomicity is equals to 2. So in this number 1 now, that means the atomicity of that element is equals to 2. Now let us see the B. The B part. An element with relative molecular mass of 32 and relative atomic mass of 16. That means for B now, atomicity is equals to relative molecular mass divided by relative atomic mass. So what is the relative atomic mass now for the molecular mass? That will be 32 divided by 16. That will be what? 2. That means the atomicity for this second element is also 2. That is for B. Just take note. Atomicity is relative molecular mass over relative atomic mass using formula for now. Then let's take the C part. Now for the C part, again an element with relative vapor density. So see the data given for the C. We have vapor density. What is the vapor density? Is 62. Also relative atomic mass RAM is equals to 31. So now, and what is now atomicity in terms of vapor density? That means atomicity will now be 2 times vapor density divided by relative atomic mass. That means anytime you have vapor density, you multiply by 2. That will give you relative molecular mass. So you can check what you have solved so far. So therefore, now atomicity now will be equals to 2 times what is vapor density? 62 divided by 31. So here 31 here 1, 31 here 2. So 2 times 2 is what? 4. That means the atomicity of that element in the third one is also 4. Now this is how we can find the atomicity of elements given relative molecular mass or relative atomic mass or vapor density. So go through this one, then we can proceed if you grab.